So now that we have the pins and the setup with the loop, this tells us what we're going to do. And in this function, the loop just runs continuously. In this code, when we run it, it's just going to do these things over and over and over again. So let's get in to figure out what is set up here. So if you actually open up a blank Arduino code, you have setup and loop. And so loop is what's going to keep running over and over and over again. And what we have here is a print. And so it's going to print out this line. And that way we can see what in the world is going on. It's giving us some text about what to expect. When we want to call a function, we write the parentheses and the semicolon afterwards. And you can see that the semicolon appears after every line. That's pretty common in a lot of computer languages. But this is how we call a function. And we'll see below that we're going to define each of these functions. And what we do here is we put another print line, and this is telling us that we've moved on to another part of the code. And then these seconds of delay are actually microseconds. So this says to wait 1 second, delay 1,000 milliseconds. And then it's going to show us the speed control line, run the speed control code, type the speed control line that's here. I'm calling it speed control line because it just has that in there. Then we're going to just delay, and then we're going to stop. And so what we have is a delay, which is a function that already exists in the Arduino code base, and we're using that. But we actually defined 3 new functions. So let's look at how to make functions in Arduino. We have void, so we're not trying to return anything. It's actually just doing this work. We've put a comment here to say that this is for controlling the spinning direction of the motors. And then what we also have put in here is to say, if you get here, we're going to print this line in direction control function. If you get to here, turning on both motors. If you get to here, changing motor direction. So we should see this in the output screen when we're running the code. And what happens is we write, and we do an analog write to the pin, which we named ENA, and that's the information that's going out through pin number 9. And when we connect the wires, it's going to end up in ENA, which is the pulse width modulation pin of the motor driver. And we can send any number between 0 and 255. We're sending 255, which is the maximum. Same for motor B. We do this nearly simultaneously. We turn on motor A first, we turn on motor B second. But to our human eye, it's going to look at the same exact time because this code executes so fast. The power should be full, and then we actually turn on the motor high out of N1 and high out of N3. So in a certain direction, we're going to go from here to here. We're going to go N1 and back into N2. We have no power there, so that becomes our ground wire. And after we do this work, we're going to delay for 2 seconds. And then after those 2 seconds, it's going to say we change the motor direction. And then it's going to switch and send out the power from N2 and N4. And so that electricity is going to go back out, but through the opposite flow. And so that will change, since we're using direct current motors, that'll change the direction of which the motor is spinning. And then we'll turn off the motors. We'll set everything to low and say that everything's off. The next function that we'll run is called speed control. And so we'll be able to write in a number if we would want to. It'll show how I goes from 0 all the way up to 256. This is called a for loop. So it starts at 0. It knows it'll stop at 256, and it keeps adding in one more number. It's doing this every 2/100ths of a second, so it's pretty quick. If you can do that math real quick, every second we're going to increase the power 50, and the scale is from 0 to 256, so it'll show 1/5 of an increase, then the next fifth of an increase, then the third fifth of an increase, up until 256. And then it'll go back down. It'll slow down. We'll take away a number every 1/50th of a second until we go from 255 back to 0. And at that point it's off, and so we will make sure that we write that all the motors are off now. In addition, we just wrote a stop function in case we needed it to call directly, and I think as you become a coder and start working with this, you'll find that having a stop function is pretty critical for staying sane, because these motors will turn on occasionally and scare the bejesus out of you, and it's good to just have a function already set up where you can just turn it back off. And so again, we put in this line here so we can see in the output that the Arduino system is agreeing that we're turning off the motors. This is how we turn off the motors, and then there's a delay here. If we run this code as is, it's going to loop. So it's going to do this, then it's going to do the direction control where we send the power one direction then the other direction. It's going to do a delay of a second. It's going to write this. It's going to do the speed control where it shows you how it goes up as we increase the amount of power that's sent to the motor, and then goes back down. And then at the end it's going to stop. But it's not going to stop forever. It's going to stop for 20 seconds. And then because this is a loop, it's going to loop back through. And so when we have the code operating in the loop, it's just going to keep doing this over and over again. And that's a way that we can see how to control the motors using the motor driver. And in a follow-on video, we'll show the code that is more about how to work with the Bluetooth itself. Again, just to do a quick final overview. We use this include so that way we can see these messages that we're sending back and forth. We establish these variable names so that way the pins are named something that we can follow, and these names are coming from the motor driver labeling, and that just makes it easier for us to understand. We set things up by declaring these pins through the pin mode as output pins. We initially write to those pins that they should be low, especially the 4 that control the motor. And then in our loop, we have a couple places where we write code that gets output so we know what's supposed to be happening. We create functions that can change the direction of the fan, can increase and decrease the speed of the motors, and then can fully stop those motors as well. And then we have functions down here. One function is from line 40 to line 69. The speed control function is from 72 to 100. And then the final function stop is from 103 to 112. So you have access to this code and can break it down a little bit on your own. There's also an accompanying spreadsheet which kind of walks line by line what every line in this document does. So go ahead and take a look at these codes, use them a little bit. Feel free to change some of these numbers, maybe even some of these numbers, and see how they influence how your Arduino Uno is powering the motor driver, which is powering the motors.